Hello everyone, I'm Xiaogang. Okay, we only have these last two items, so we won't walk you through them. It's a bit complicated. Actually, you won't use it often, but we will discuss it briefly. Basically, just like the TMap we wrote earlier, if you treat this structure as an item after serializing these two things, you can place it in a TET and use it. Because its technology and elements are also items. So let's first look at the first case. In reality, we can find this here. You can just perform a global search for this item, and then I can quickly check something out. Let's take a look. That's it. You can just take a look at it. You can see that it's a struct, right? And inside, there are some properties. These are some of its constructors, and it overloads operators and so on. And they check this property. Is this attribute equal? And at the same time, it overloads this place. Gate top hash. Then you see these few questions can be used for TAT. So basically, it's like this. One is getup HEC. One is this equals sign operator. It just depends on how you operate. But sometimes we might need. Maybe our structure cannot, because this ellipsis has a different meaning. That is, we might have other properties to compare, and not just using a simple one. Then you might need to specify a T-key function. Something like that. You can see here, this place also has a set, and this is int s, and inside here is its key function. Then this is the one stored and allocated in this class, right? How to allocate elements. Take a look at this place. This place, TSet flam, the fake key function flam. So we will mainly look at this default key function. If you want to customize it, you can inherit it and then follow its implementation style. We can just implement it. But regarding this part, it should inherit this, it should inherit it, and then continue to implement. It's also this defi function, and then it defines the corresponding one here. This key init element net pipe, and then defines two type lines. 3 state methods. Let's match them up. Everyone knows. Look here. This knet type, and this place is element init type, actually element init. It is no longer our T pair. It is actually this TSet element, and the K in a type is what you use inside the element. This structure has many attribute values. Which attribute value are you using as Kate for the calculation? And this place returns the key value, and then it's about comparing if two key values are, and then it's about calculating the hash of the key value. You can roughly follow this to implement it. So that's roughly how the default K function is used. But there are some differences. Okay. So if you don't know how to use it, you can directly search globally within the engine. Take a look inside the engine. How to use TSet. Then we do this default key function. We actually don't really use it now. And in the end, it's actually still the same. There is a usage status for this current container. And in this location, this CountByte is when we serialize, we will use the engines. This FOutputDevice is from the engine, a dedicated type of serialization method. If I get already the quality side, that's what we can use. And this can be outputted to this output device, and this might contain all 3 consecutive pieces of information. We can click into it to take a look. We click into a TSet. Let's take a look at what was presented. Something like this. Then, if we use F6, we can search within this document. If it's not here, maybe he just doesn't care. You found a dump in this spot, right? Alright, let's wrap up here. Just mentioning this briefly will be enough, because these two things are pretty similar to what we covered before. They also aren't really among the main focus areas we need to study right now. Alright, so we'll wrap up the basic set container here. In our next, or the segment after that, we will quickly move into some practice and study of the code for gameplay elements. Because containers are really important, therefore we will focus mainly on TArray and TMap. TSet will be used, but to a lesser extent.